prefer to use Linux, which are Linux only activity, but you can also use the Windows. So for example, if I show you my Windows experience, I close the remote connection. Let's say this is my Visual Studio Code now. I can create a folder. Let's say I open a folder. I open a folder, and then I go to my, let's say, desktop, and I can create a folder. And if I say that Python class, and then I open the folder as newly created, the Visual Studio Code opens in that folder. So you see that it shows you the Explorer, which is empty right now at this point in time because it's just now created. Now, if I create the first .py, the extension for the Python, you can see that little icon shows up. It is coming because I have installed this Python extension with my Visual Studio Code. Now, you can see that it gives me a lot of, let's say, funny stuff because I have got the GitHub Copilot, but just ignore that. But you will find this empty thing. Now, if you, let's say hello, this is the first check we can do with any Python installation, whether it is working fine or not, right? Now, how to run this? Now, there are a couple of ways by which you can run. One of the crude ways of running it is that you go to this command palette. So how do you open the command palette? So you have got a couple of ways to work with the command prompt directly within from the Visual Studio Code. So you don't need to, let's say, go to command window, bring into the folder and do that. You can do it from within this Visual Studio Code, right? So you can actually go ahead and go to this command prompt palette by typing control tilde. That's the key before this thing. So you can see that it opens the command prompt within the Visual Studio Code in this path. So you can see that this path is already identified. Now, if I have the Python installed in my local machine, I can say Python and it shows me this prompt, which means the Python runtime is installed locally in my Windows operating system, which is Windows 11. Now, to exit out of this, you say exit, close or open. To run this file, you need to provide Python and the file name. So if you say Python and the file name is first.py, that's the way to execute a Python code. Now you can see that it is printing hello world, which means it is working fine. So all this is the basic confirmation of whether my Python runtime is installed properly. My Visual Studio is able to, let's say, write a file, and then I get all the Python related help which I was getting. And also, if you have the Python extension installed, you get to see this small run icon on top called run code. If you run this, it runs directly without you typing Python file name. So this is also a helpful activity you can do. Now, this is the Windows experience. It's almost the same when I open my Windows subsystem for Linux, which is what I'm gonna use now, right? I'll do the same thing, just a revisit of what I have done earlier is that I'm gonna create a folder. Let's say I'll create a folder. So I create a folder and go to that folder, and then you open the Visual Studio Code in that folder. Benefit is that all the files you create stays within the root of that folder, right? So I go inside that. You can see that now it is showing me WSL for Ubuntu. If I press Control tilde, it will open basically the Linux prompt. Now you can see that this is a Linux prompt. So if I do ls, there is no file right now at this point in time. So I can go ahead and create a file. To create a file, you can do it from the Explorer within the Visual Studio Code. And you can say first.py, the same file. Everything remains the same. Only thing is that I'm running it against a different, let's say, kernel. Now if I say print and I say, if I say so, and then I can hit run, it runs the Python code in my little window below, and it displays that, right? And we're going to use this kind of activity going forward, but I wanted to actually cover a lot of area within the Python. So the intent is to tell you many more features within this short span of time. So what I'm going to use is something we call as Jupyter Notebook. One of the best things about Jupyter Notebook is that if we use Jupyter Notebook, we can continue to run that in a large file and run only the section of the code. And once we are done with the class, I will share the Jupyter Notebook so that you have the whole source code with you for your reference. So that way you don't need to, let's say, do things with me. You can follow, and then we will, I already have created a Jupyter Notebook just in case we cannot cover the whole content. But in case you want to, let's say, refer, it will be with you. So don't, so that way Jupyter Notebook is helpful. So there's another way of, let's say, using or running Python, which is a very common practice within the data science community. People who use the data a lot, play with the data, they use Jupyter Notebook quite a lot because it's convenient. You can execute a block of code. You don't have to, let's say, create a file and then do things, module it, and all those things. It's a very quick way of executing. So let me give a name, Python class, and the extension for the Jupyter Notebook is IPyNB. And then if I do that, you can see that now this is a little bit different view. It opens in the Visual Studio, but it is detecting the kernels. Why? By doing the detecting a kernel means it is finding what is the runtime it's gonna go ahead and use, right? So that's what's happening right now at this point in time. Once this loads, you will see that the Jupyter Notebook is kind of ready. So let's just wait for a moment to load it. But in the mean, hi, yeah, hi, Sanjay. So Visual Studio Code is good enough for that, but there are dependencies which gets installed once you, let's say, initiate a Jupyter Notebook. So if you say IPyNYB, Visual Studio Code will automatically ask you to install these things. So you can see that the Jupyter Notebook extension will come. So they will prompt you automatically. So because I already have it, it didn't prompt, but this extension will be installed in your machine just so that you get this interface, right? The moment you create that file. But yeah, but Jupyter Node, yeah, no, go ahead. Uh, you don't have to install. I am using Jupyter Notebook for my convenience because then I can use the block execution, right? And the execution is faster and quicker, right? Just in case like Jupyter is taking time, but we'll let it happen, right? But let's say that Jupyter Notebook is not a mandatory for this class. Yeah, yeah. So let me continue. It's taking time. I'll come back to this. So let me say that, put a little bigger. Okay. Now this is the first test which we do with any, let's say, hello. Now you can print anything and everything. So print is basically to print any Python object into the screen. So if you say 100, it prints 100 in the screen. If you say Boolean, let's say true, it prints Boolean in the screen, right? So that's how it prints anything. So any object that's the reference gets added. Now with this, you could see that though they look simple text in the screen, but they are basically behind the scene different data types. Now let's understand a little more about basic Python data types. So you have the number data type, numeric. So Python doesn't want you or need you to explicitly call out what is the type. So if you say that I want to declare an integer, positive integer, so you just say a variable name equal to and the value, and it will figure out that it is an integer. Now, if you just print that number, the variable, it prints 10, 100. But if you, let's say that I want to check the type of this num, then it will tell you what is the data type it is holding. So you'll see that it now tells me that this is an integer data type, right? Let me see if that has come up. Yeah, that has come up. So let's switch to this experience because then it will have the better view. So let me kill this. Yeah. Now what I'm going to do, I'm going to just declare a couple of data types. I'll say 100. And if I print num, and if I print type of num, let's say, and then to execute, you can say Control Alt Enter, or you can just click this button. So you can see that it's executing here. So it's clean way of executing. Now, if I, let's say, declare another type of variable, let's say I will say num equal to 10.25. Now 10.25 is definitely not, um, let's say, so I'll say num decimal num. So it's definitely not an integer. So it'll be considered as float. Now let's not print this. So you can always comment your code using this hash, and if you do that, then it will not execute. So I can just comment them out so that it doesn't print, so that it doesn't look busy. So it can see that it is type float. So it's another type. Now I can continue to change this so that I don't have to type a lot. And then I say that hello. So if you say so, it is string, right? Like that, you can have a Boolean, true, false. So you can say true, and then if you execute, if you execute this, it will say bool, right? So these are all standard types which are basically used. One of the very commonly used data type is datetime, but that is not part of the core Python library. You need to import an additional library to work with date and time, and we'll see how we can import that. But these are all majorly the data type like decimal, int, bool, num, text. Text, not num. Text, Boolean, decimal are the types which we typically use in the common activity like working with the Python code. Now, from a mathematical operation perspective, if you have, let's say, two variable, let's create a variable a equal to 1 and b equal to 2. And if you use the common plus thing, it becomes like, let's use something like 3. If you use 6, so if you use this, it becomes like an obvious that it's a plus b, which is 8. It's easy to do the mathematical calculation. If you change it to divide, so it'll be div 3, and you can see that it always gives you, though they are integers, it'll give you a float because you never know, like you can have 5 divided by 2. So the result, to be on the safer side, Python keeps it in form of decimal, right? So that it can give you the right result. To do multiplication, you use this sign, typical calculator buttons, right? So computer based. So you can see that it is very simple. Now, if I go back to the previous state, that is our plus, and if I, let's say, change this to two different letters. Now, if I use the same mathematical symbol here, plus, this is not going to, let's say, add. The add for text is append, right? So it will be adding hello. That's why I kept a space. So hello, and then the world will come after that. So you can see that now the output will be hello world. So it's like the same symbol changes based on the different data type. Now you can mix and match. Now if you say, I want to mix and match with a equal to hello and b equal to 2, but then this Python is confused, right? What to do, because it has got both string and integer. Now, if you see that, it is going to throw me an error. This is an error in Python because it is trying to convert something and trying to do and then trying to figure out on its own, and it's unable to do that. So one of the recommended way is to convert this into whatever the desired output type is. So I am definitely looking for, let's say, hello 2023. So I am definitely looking to produce a simple string. So I am going to convert this uh, number into a string. So if I do that, how to do that? So if you say str, that's the data type, and then wrap it around with a number, anything you can convert it in string. That's the safest way of conversion. But from anything to integer is not safe, because if I try to convert hello to an integer, it's not going to convert. It will give me an error. But if I have 1, 2, 3 written in double quote and then try to convert it to an integer, it will convert, because that's the kind of like way around. But anything to string can be converted because everything is string, right? So if I now run this code, you will see that it is now going to convert the 2023 and append it as a string after hello. So it is working fine, right? So this is how you basically use this um, one single common operation, that plus, for a different kind of activities, right? So for example, now you convert it to, let's say you change it to true, and then you change this to false, okay? And then you, let's say, do an addition to two Boolean values, true and false. So true and false is 1, okay? So what it is basically trying to do, it is trying to convert the A into integer and B into integer. So I'll show you what happens when you convert A into integer and B into integer in a print. Let's say if I say type of A and type of B, you will see that A will be 1, it'll be 1, and this will be 0. That's how the conversion to integer will happen. So you can see that it is both a type, and then if I print this A as int of A, and then if I say print, let me hide this, hide this, and the result. So if you just execute it, you can say that first one is 1, that is true, and second one is 0, and hence by doing this you can actually get, you don't need this bracket, it was from the past. So if you run this, you see that it is going to give you the output, which is simple, 0 plus 1 is 1, right? That's why you see two Boolean value. It's one of the interview questions, by the way. So two Boolean value getting added as integer. So you can actually find things like like converting different kind of value and then doing the add. You can also convert true and false to string, and it will become true, and then the other one will become false. So this is how the thing will look like. Now let me keep it and add one more section. So here what I'm going to do is that I'm going to, yeah, yeah, should be 2. So let me change it to true, and let me try this. The result is 2. Yeah, you're not explicitly converting it to integer, Python is doing it for you. Yeah. So if you see here in this, so I put a string called hello world. Okay, now let me show you a couple of string activity. There are certain functions, we call it method, within the string, which helps you do a lot of things, which typically we call it as string manipulation. Now string is a set, which means that it has in each character within the string is an element within an array. So if you consider this whole hello world as an array, each of the letters are the item within the array. That's how Python considers string as an array. So because when it prints that way. So internally within Python library, they consider each character and then put it one by one. So that's how they print it in the screen. That's why we see this output. But if you look into this, so let me hide this line. Let me try showing you some of the basic Python, let's say, um, outputs. So if I use as print, let's use this common output, out, and then I use this out to change this string. So what I'm going to do is that I'm going to use various different methods to change it. So first I will use the lower. If I do that, now the whole hello world will be in small characters. So you can see the output of the hello world is all lower. Now let's replace it. So we'll keep it so that you see the different output. Now if I see that the hello world is now all capital because I use something called upper. So these are all functions built in within the Python library. Now, if I, let's say, use this h as a small h, and okay, let's keep the w as w, and if I use this out equal to s dot capitalize, yeah. So there's a function called capitalize. If I use that, I can see that the first letter or the first word is going to become like it's a sentence case, we call it sometime, is capital, rest all are small, right? Similarly, if I have, let's say, W as small and H as capital, now if I use this same out equal to S dot title, that's called title case. So in a book title, right, you have got all the first letter of every word is capital. So it'll become like that. So though I have got small w, right, I still will have hello as W capital. So title case is converting each word's first letter into that. Now, I can also do a swap case, which means that it changes whatever is capital becomes small, whatever is small becomes capital. So you can do that. Now you can see that output. It shows a little weird, but it changes things, right? So W is small, that's why it is showing. So if I have the W is capital, now this will look like this. So it is programmatically looking into each character of a string and changing whether it is, if it is capital, it is small, then it is small, it's becoming capital, right? You can replace a specific character or set of characters from uh, Python. So you can see that is also recommending because I tried that same thing. So you can see that I basically can change the word, replace the word into Python. So replace is a very common string manipulation activity. So if I execute it, so you can see that hello Python is coming instead of hello world, right? And then you want to identify like what is the kind of like length of this whole sentence or the set of things. You can use a function. So length should be used as len s. So it will give you a number, which is basically the number of characters you have, including the space in this whole hello world. Now, if I just go ahead and change a little bit and put a space before and after, you will see that the output below should now reflect that 13. So it calculates the character including the space. Now I don't want this extra space before and after this hello world. So you can either go ahead and replace the space, but by replacing the space, it will also replace the value, the space within, right? So you have to put an if condition. If there is a word before and after, I will not do that. So it becomes a little complex, right? So Python gives a function already called strip. So by using strip function, it's basically trim. Okay. So if you if you consider a set of characters before some spaces and white spaces, they will remove the white spaces before and after and make it. So if I do a trim, and you will see not only the output, but also let me get you the length of it. So I can also use like this. So it will give me now the length of this hello world, which has got a space before and after, which is supposed to be 13 as 11. So you can see that. So that means the trim function or the strip function, trim is basically a function from C sharp. So this function is helping us remove the extra spaces, which is not necessary for the data science activity. You need to remove those white spaces, unnecessary white spaces when you get a word. So it does really help you do that. Now we can make an array out of a sentence. So let's say I want to make an array of, let's say, all the words. So I say hello world, Python is an amazing language. So I have that bigger sentence now. If I now create an out and then say split, and then I split based on space. Okay, so you need to define like what is the criteria based on which it will split. So do you want to split it based on a comma, full stop, or semicolon, anything like which is kind of differentiator between two things? You can use that, and as it finds in the screen text, it will keep adding those as an element. So let me quickly run that. You can see that this is an syntax of an array. We'll come to that later, but this basically creates a set with individual words in it. So if you are, let's say, trying to count how many words are there in a passage, so if you copy a whole text and then you want to calculate that, you can split it and then calculate the number of words create an array with the space, and then calculate the length of that array programmatically and give you the number of words. So we always use that from an end user perspective at our word. So we see number of characters, number of words in our word when we type things in word. So same way you can also programmatically figure out the number of things. So you don't have to run through. So these are called utility functions in Python, right? Now we have been using so far as line, but if you, let's say, have a larger text with multiple line, you can actually put it then it starts showing you an error. You can see that these are squiggles error, right? So to have a multi-line, you type 3 double quotes. You also need to end it with 3 double quotes. So let me put it down and I say, okay. Now you can see that I just keep typing what it suggests. This is just something random. So you see that now the string is quite large. Now if I just go ahead and let's say split it again, you can see that the /n identifies the new line. Okay, so it comes up and it splits this into multiple words and then it consider the whole thing. So if you have a long, very long text, you don't need to put it in a single line. May not be the right thing to do if you do it. So you can continue to copy the whole text. Let's say you copy from a newspaper article, put it as a paragraph. Multiple paragraph also is fine. And then you put it in the 3 double quotes, and that will allow you to create multi-line. But remember, it has some hidden character which we are not able to see. Each line contains /n. That's a new line, and that new line comes up when you do a split. So you can see that hello has a new line because it starts in the second line. I didn't start hello from here. So if I would have started hello from here, that new line will not come. So let's run it and show a little bit. So hello doesn't have new line now. So that's how you can figure out like how do you do that. Now let me show you another interesting aspect of print before we move into the next section is when you have a complex things to print. So one of the ways you can print a value within this, saying that hello, and then I go ahead and declare a few variable. Let's say I say name, I use my name, and then phone, I use some phone. Okay, and I want to give, let's say, a message or print a message based on these two variables. So you can do a plus and name, and then let's use this. So you can see that this is going to print my name with my phone number, and then phone number is getting converted into string. So if I would have taken the phone number as a string, sometimes makes sense, because then you have dash, comma, all these things for the numbers, especially coming from the international number. So you have plus, bracket, and all this stuff. String is fine, but if it is not, let's say it's a pure integer, then it should be converted into string. Otherwise, you should wrap it in double quotes. So if you wrap it in double quotes, you don't need to convert it into as a string, so we can get rid of this phone number. So let's get rid of that, because let's focus only on the string. So if I run this and I see that this is now going to create a thing. Now it can become very, let's say, lengthy and complex. Now to do that, we have a better way of printing it. So you can see that if you use this placeholders, we call it as a placeholder, you can then place them based on the sequence. The first one will be this one. Second one will be this one, the same output. Now let's run both of them. Let's say I execute it. Now both of them gives me the same output. Now if I copy this one, and I can change the placeholder, and I say that I want to first print the phone number and then print the name. So this inside the format, the first parameter index is 0. So in programming language, generally the index always starts with 0. So anything you identify as 0 is the first element. So first element is 0. So I'm just replacing them by using a placeholder with a number, right? If I place something which is out of context, let's say 2, it will give me an error. Let's see the output. So it will now show me 3 output. So you can see that this is the first phone number is appearing, second is name. Now I can have, let's say, n number of values in the format, one by one, all the variables, and place them as and when. I can place my name again and again, right? So if the text requires me to put my name again and again in multiple places, I can just have the name in the format in one place and use it in multiple places. So I can even, let's say, type my name twice. If I have phone number twice. So let's say this one represent phone number, not name. So it will be printed twice. So you can see that it is now up to me where I need to place it. It's not bound by, let's say, only the sequence. So this is very hard-coded way of doing it. That means it is bound by sequence. You cannot change it. It will always go sequence. It cannot repeat. But this is very flexible. And this is preferred way of printing an output in a complex kind of scenario when you have to build a message. Now what I'm going to do is that I'm going to use another string. Let's say s. Anything you do comes up automatically, so I'll use that. Now let's say I want to print find. So I want to find something out of this. So I say s dot find. The find is finding a text. Let's say hello world. So what do you think it should return me if I start finding that? It will return me the position of the first letter. Now position starts with 0. So this is 0, 1, 2, 3, 4, 5, 6. So from sixth position of my string, this word is starting. So if I execute it, it should give me the 6. So you can see that it is giving me now 6. Now I can try to find something which doesn't exist. So let's say small w. It doesn't match. Okay, it's not as independent. Sorry, as intelligent as it should be. but it doesn't match. So you have to be explicit. So you need to convert the whole string into Lua and then convert the whole find word into Lua if you want a case insensitive find, we call it. That's what we need to explicitly do it. But let's try to find which is not there. That's word. Okay. So now this will give me something, a negative value. That's -1, indicating that it doesn't exist. Okay. -1 indicates it doesn't exist. So if I'm trying to find a word which doesn't exist, -1 will be appearing as an output, and I will say that it doesn't exist. Okay. Otherwise, it'll give you any positive value starting from 0. So if you say hello, it should give you something as 0. So if I execute it, you can see that it is showing you 0. That's the beginning of the word, right? That's how we identify it. And the word with small w doesn't appear. But if you start with word with capital W, it shows you the value as 6. That's the find for Python. Now, there are a couple of, let's say, formatting options available in the print also. Let me show you a couple of them. If I now enter a print, okay. Now I want to print them into two separate lines. So I can press enter N and I can just put it alongside with word so that word comes in the same indentation of the hello. And if I just run it, you see that hello world comes. If I have a space, it'll look a little odd, but it basically identifies that /n is the new line. Similarly, if I use /t is the tab. So it will have a tab space, couple of spaces together. Then if I want to enter a slash, okay, backslash, and if I start typing that, it shows you like this. If I want to enter, let's say, double quote, now that's a problem because double quote ends the statement, right? Now, how do I nullify this double quote and say that the double quote is not my string declaration? This double quote is basically a double quote. Okay, it's let's assume is a character. So to nullify this double quote, you basically do that slash, and then it becomes this double quote. Okay, same with single quote. So you can't just like put a single quote here. So you just use this, single quote comes as a single quote. All right, so let me go back and then go to the next phase. So enough of string. Any questions so far? Yeah. Hmm. Hmm. Yeah, so we can. So let's say you have this to find. Okay, you don't find. So if you say print this, then it will find. Why? If you read it now, what it is trying to do is that it's trying to convert the whole string into Lua. Okay, and then also it is trying to convert the whole string, the find word, into Lua, and then it will match. Then you will find 6 as probably the placeholder for this as an output. But if you don't use these Lua function, then as is, it won't find. It will give you -1. So this is the case insensitive way of finding things. Yeah. Okay, so let's move on. And then let's say use some integers. Okay, so let's say 10 b equals 20. C equals to 30. So let's keep C, but we'll use A and B for the most of the time. Now, if I want to, let's say, check a condition, whether A is greater than B or not, something on that line, what I can do, I can, in Python, I can use a condition. So if is, so you can see that it changes the color. It's a keyword. So if you say A greater than, if A greater than B, and the syntax ends with colon, and then you can print A is greater than B. So what this statement really means is that I check if A is greater than B, then it's greater than B. Well, this is not greater than B, so it should not give me any output. You can see it's empty. But let's say if I change the symbol to A is less than B and I execute it, it definitely is going to print a wrong one. I'll say less than B. Okay. If I just run that and it becomes A is less than B. So this means that the statement is executing okay. However, if you go ahead and let's say also want to read when it is not, in my previous case, let me just go back and keep the default one. This is not printing anything. So if I run it, it's not going to print anything because it is not, the statement is not true. But I also want to know when it is not true. So to do that, if I say else, now else is everything else. Now the else is either B is bigger than A or A is not bigger than B. Something like, which is meaningful, you can print. Now this will print because this is going to come to the if first, checks the condition, becomes false, and then it will come and execute in the else. Now I'll change this to less. Now this will print a wrong output, but it'll print the first one. Okay, let's see. It is wrong, but it prints the first one. Okay, this is where it is coming and then printing. So that's why the if is very, very, very important in programming language, because programming language is all about logic. So you find the logic and then you basically execute the logic step by step, and you take a call based on whatever, let's say, the value you are providing. Now it can become a bit more complex because, for example, let's say I'm fine, I'm checking A is greater than B, printing A is greater than B, else A is greater than B. But I also want to explicitly check if, let's say, A is also greater than C, because I have got something like a C. So let's put else. Now that if you want to put another if condition, you don't, let's say, write another if condition, you can maintain a chain. You can see this, it's giving me some suggestion. So basically el, that's from else and if, and then you can put a condition like if A is greater than C. Now I say print A is greater than C. A is also bigger than C. Fine. Now none of the above. Let's put a different print statement. Now, now in this condition, A is 10 is definitely less than B. A is 10, definitely less than C. So it's going to print the last one. So let's see. You can see none of the above. But if I change it to 100 and if I execute it, now you can see that A is bigger than B, which means that it ends there. The moment it finds the first successful one, it ends and comes out. It is not checking for C. My purpose is also to check the C. So in this case, what you can do, you can copy this whole thing and put a nested else if. So you can say else and paste it. Now let me show you a little by little formatting it. Indentation is very important in Python. Now this is where it comes in. So first statement, when it says that A is greater than B, which is true, is coming. But if A is not greater than B, right, then it should come on inside the else condition and check if A is greater than C. And to make A is greater than C, I need to see, let's say, reduce the C to 3. So then if it will be A is greater than C. Okay, and say that, and then none of the above. Okay, so let me execute it. Now I change a couple of values because to satisfy the output. You can see that it is showing me A is bigger than C, which is true. A is not bigger than B, but A is bigger than C. But in the previous, if you just retain this, let me copy this and then Control Z a couple of times, go back to the previous state. It is not going to come to the next else statement, if statement, because it is true here. So with this sequential elif kind of thing, it is depending on the condition and the situation you need to take, whether you take a call whether you need a nested else if or a sequential else if. If it is sequential, then you remember that whatever step it finds first the true, it comes out of the whole if statement. So if you might have, let's say, 20 different condition after this, all will be ignored. So depending on that condition, you will be doing that. Now there are a couple of other symbols which you can use: greater than equal to, less than equal to, less than equal to. If you want to check equal to, so you say double equal to, not equal to. So these are all typical, let's say, operators which you typically use. Greater than and less than is very simple, so you have seen it, but these are all other things which you can do that. Now if returns true, then within that if, so you can see that indentation is important. Within the if, this will be block will be executed. It can be some mathematical calculation, it can be something else, it can be a database update, anything of that sort. But within that if, the statement will come. Now let me go back a little and then add this, and I show you something very interesting which is commonly used. I will call it a collection. So let me put it in name. So if I say collection, now collection in Python are many different types of collection. Think of it like an array, set of values. In an Excel file, if you create number of rows with one column, right, and all of the value contains number 1 to 100, and you think in Python, that's an array. Okay, so how do you define that? Very simple. So I'll say lst, and you define like this. So it holds the value 1 to 9. Now, how do you deal with it, right? You need to print a certain value. It starts with 0. So if you print that, it shows you the first letter, first element. And if you, let's say, I want a fourth one. So our fourth one is 0, 1, 2, 3, and 4. So fourth one is 5. So if I execute it, it will give me 5. So like that, you can use this variable. But if it is too big, let's say you have 1000 values, it is not so convenient. So, but I want to, let's say, check all the items and see if they are, let's say, having some certain condition. So to loop, so with collection, loop comes in. So which means that, but before that, let me show you a couple of other things. Let me show you what is the type. It's also a data type. Okay. So what is the type? It is a list data type. Okay. You can even sort a list. Okay. You can even find the number of elements within a list. To find a number of element in the list, you ideally should be using same len function and then say lst. If you do that, it gives you there are 9 elements in the string. Fine. Now I want to go each by one and print all of them. Now for that, in Python you need something called a loop. So loop can be different kind of loops. So the simplest one is for loop. So I'll say for item in LST. That's a variable where the array is holding, and I print the item. Now this, what essentially this means that it goes through each of the element and picks up one at a time and then assign the value to an item and then prints that item. And then it goes through no matter how many items you have in that loop. So if you run this, it is very convenient that it runs all of them. If I, let's say, copy again the whole set of values and paste it after that, so it becomes now 18, and I run it, it prints all of them. You can see that all the 18 values. So I can clear the output, show you that it ran fresh. So you can see that all the 18 values are coming up. So it is very, very convenient for me not to bother about like how many elements are there. Let the loop handle how many elements are there and give me each element one by one and let me do what I want to do, right? So rather than finding what is the length of an array, how many times I need to go to that array, and then doing the hard coded square bracket and the number to find that element one by one, it's too much. Okay, let's use some internal intelligent way of doing things, that's using loop. Now you can notice here that I can go up to this, but let's say I am going to use a sequential number. In that case, I don't need to explicitly call out these numbers. I can use an inbuilt function called range. Now, by saying range 10, I'm essentially doing this. So when I say range 10, it starts with 0, go up to 1 minus 1. That is up to 9. So let's see. Now this is a comment, okay? So this is, make sure that this is not, don't differentiate between the previous one. It is a comment for our reference, but if you notice here, it prints 0 to 9. If I print 100, it'll print 0 to 99. So let's see that. Now, sorry. You can see that the output is quite lengthy. It's also not having some dot dot dot, just to identify that it's a truncated, so that I have that scrollable thing, so you can scroll. So this is a little convenience way of working with Jupyter Notebook. But in normal command prompt, if you run this code, it'll print all 99. Okay, so this is printing all 99. So the range is quite helpful one. Now we can actually control the behavior of the range. So let's say that I want non-zero. So I start with 1. I use 100. I start with, let's say, 2. Okay, and I use 100 and I go step 2. That means all even numbers. Okay, so if I do that, you can see that 2, 4, 6, 8, 10, you can get all of them. You can even, let's say, get things like start from 5 but jump 5 element at a time. If you do that, then you can see that the range is giving you all the elements 5 plus 5 plus 5, 5, so on and up to 95. Now, if you want also to capture 100, you need to just use 101. Then 100 will also come. So you can see that whatever the final value, minus 1 is the value, because it starts with 0, right? So if you say 10, it will give you 10 element, but it starts with 0. If you want to change the behavior, you change the behavior to 1. So let's say I go back to the simple one. I start with 1, go up to 11. So that is going to give me list of values starting from 1 to 10. Okay, so if I say that, you see that I'm getting all the 1 to 10 values in this iteration. So this basically is the the way of handling loop. So loop is another intelligent way of working with the data, especially the collection kind of data. Now, one of the other things about this list, if I remove this, and I create a list. I can mix and match things. So I can say that I want to have 1, 2, 3, and then I can say 1, something like that. Let's see if it works. So it shows all the elements. So any kind of data type can be clubbed together in a single list, basically, because it's like collection of data. So like if you imagine Excel, in a row you can put number, you next row you can put a date, you can next row you can put currency, you can put anything and everything that can be complete different from a data type perspective or the data kind of data you are trying to enter, but it can hold everything, right, for you. So same way. So in the list, you can hold anything together, clubbed into same collection, and then you can loop through it, each element, and then you perform whatever way you want to perform. There are certain, let's say, complex way of handling things through collection. There are different types of collection like tuple or tuple, we call it. And then there is something called set and dictionary. But I will let you explore those different types. It's a different way of, let's say, um, um, calling or declaring those type of things. I have got this Python notebook, which I'm going to share after this class. Will have those values. So you will find like all those kind of different type of data types available over there, and you can play with that. And the loop works for all of them. You can loop through any collection. A loop is meant for that only, right? Now let me show you another different kind of loop. Okay, not just for, but let's say when you have no collection, and then you need to go through a sequence. So we have a commonly used loop called while, and we can start with a variable. Let's say I start with a variable I equal to 0. Okay, that's the variable starts with the value. While I say I will run the loop while I is less than 10. Okay, and once this is done, I'll just print the value of I, and then I will increase the value of I. Each time I print the I increase until it reaches to 10 when it exceeds the loop, right? That's the loop, while loop, we call it. It's same as the previous one called range, but it's a different way of writing it. Now you can do a lot of things. You can say that I want to print all the, let's say, squares of the value. So I square I. That's a little math fun. So you see that it starts with 0. So I'll stop. So let me change it to 1. Let's directly do that. Okay. And then let's keep it here. So what it's going to do is that it's going to go ahead and print all of these squares for all the items I'm typing. So it's basically, you can do different things over here. Now, once this is over, you can also use else with while. The loop is over. Okay. Something to identify that it's done. Okay. So you can also add while, which means that when this condition is not fulfilling, it'll come to else and come out. Now we can also, let's say, put a condition and exit out of this. So inside the while loop, you can put an if condition saying that if I is equal 5, break, which identifies clearly that it's going to go come out of this while. So let me run this and see that it is going up to 25 only and then exiting. If it is 5, don't print anything. Let's say I don't want to know what is the square of 5 because I know it already. So you're going to use continue. So it will say it will not print 25, but it will print everything else. Okay, let's see. So you can see that from the output 1, 4, 9, 15, oh, it's printing 25 again and again and again and again. Oh, there's something wrong. Let me just put it here. let me add this on top. So little, okay, now it should work. Now you can see that what this is trying to do. It's interesting, right? What it's trying to do is that it finds I equal to 5 and it is continuing. By putting a break, it is breaking. So let me show you both the things. It breaks till and goes till 16 and breaks. But if I say continue, it continues after 25 also and goes up to that. So in a complex scenario where you have, let's say, millions of rows in a data or a set which holds large data set, in the big data analytics which is very commonly used, you have got large data set. You need to do this condition while checking. Let's say if the row is empty in a CSV for kind of Excel file which is being shared with us, which comes from, let's say, a sensor data. Maybe our row is completely empty because there was some problem. We want to ignore that. So you can use the continue. So you can check that if I is empty, continue. So go to the next element. Let's not do anything. So all these conditions, right? Or you want to, let's say, only pick up the first 100 record and then break it. So you can also do those if condition within the while. So you basically, while running a loop, you can check things and then um, run existing values as you wish to do that. Now, while we have done so many things over here, when you execute code, you execute in a form of reusable code. We have been writing the code and then we have been copying, pasting, and then executing it. But let's call a function. So a function or a method in Python allows you to do an executable way of doing it. So let's say I want to do a simple um, mathematical add function. So if you call a function called add and pass two parameter a and b, and then you can just say that I want to print a and b. Let's print them. Now what I can do, now I can call this add function with different values. Now same function a plus b is being called with different parameters. We call it parameters. So this is the first parameter, this is the second parameter. So if I now run, and this is the definition called def. So you start with a keyword called def, give a function name, pass on the parameter, it can be empty also, pass on the parameter, and then keep changing the value of the parameter to get different results. So this is called reusability. In terms of reusability, you need this kind of approach like function, method, whatever you like call it, you can call it. A function can be parameterless. So you can say that I want to just say hello. Okay, if you do that, you don't need to pass on any parameter. You simply call it. If you call it, it calls the hello as an output in the console. You can see that it's printing. But if you, let's say, pass on a parameter called name and then the hello comma space plus name, simple way, just a concatenation. And if I say hello and then execute this code, it's going to go ahead and print hello Viju, which means that then this is basically taking. So I can change it to 1, 2, 3, and then it gives me the output like 1, 2, 3. So you keep changing the parameter value, it keeps changing. Now also you can, instead of, let's say, directly printing from that, because you don't know where, who and how they will use, we ideally should be returning that. So to return, it's a simple approach. So instead of say return, and then you return the value. Okay. Now this is not going to print anything. So if you run it, it's going to give me double quote, but it's not the actual output. To get the actual output, let's say you have to capture it in a string. And when you capture it in a string, then you can do a print, or you save it, or you do a data manipulation. Depending on what you want to do, you can see that. Earlier, it was only giving single quote. That means it's a console output, not the real output. This is the real output. You need to capture that in a variable and then print it, or do whatever you want to do. So when you do return, it doesn't print. When you write print inside a function, then it prints. But we don't write print inside a function because we don't know who is going to use that function. Maybe somebody who is not running it in console and then never bothered about the print output. They're not looking at the console. It's some automated process. So then print doesn't really make sense in the function space. So always return is the way of doing it. Now let's say I want to say divide div function, and I use a comma b. So what I'm going to do is that I'm going to return whatever I am dividing, let's say between a divided by b. That's the output. So I pass on two values. Instead of returning, let me print it directly. So let me make my life a bit easier. So I just directly say print a divided by b. Okay. Now I'll say div function and pass 10 to, let's say div function 10 0. Now that's not complicated here. So let's first run it. So it is giving me 5.0, which is fine. If I change this to 11, it's going to give me some decimal value, 5.5. All fine, all good. The problem occurs when I try to divide it by 0. In computer, we can't divide it by 0. It basically, in mathematics, returns infinite. So if I just do that, there is an error called zero division error. So there is a problem. It is breaking. It is not the right behavior of any application to break a code. So people can enter anything because you have allowed them to enter any value, but you're not checking. You're not checking whether b should not be 0 inside that. You can put an if condition, check the b should not be equal to 0. If it is 0, then you should give a different error message. But we're not going to do that. Let's say we allow anything and everything, and there could be many different other errors also. We don't know yet. So let's handle that in a different way. So we'll do this result as C. Let's say this is the C. But before we call this result, we use an exception handling or error handling using try. So if you do that, try, and then try to do this. And then when there is an error, I say an error. We don't know what is that error is yet. We just know there is an error, but this will not break my code. So if I execute this, it gives me an output, nice output. It doesn't show me a runtime error or there is no, let's say, application breaking, but I'm able to elegantly handle. So it could be divided by 0, it could be anything else, right? It could be an empty value also. So for example, if you send an empty value or a value d, something like that, it's still error, right? It's not a divided by 0 error. But let's say if you don't use it, if you don't use it and try to execute this code, let's see what happens. It's called type error. It's a different error. So I said, like, in this function, there could be n number of different errors. You may not know all the different kind of use cases for the errors. So to handle that, you should use this error. Now, you can also elegantly handle this error. Instead of randomly doing a generic error thing, if you know the possible error types, you can handle it. So let's see. how we can handle this. Let's enable this try catch. If I say except, and in that except I say zero division error, can't divide by zero, except type error. Let's say print, please provide the valued input type int or decimal. Be explicit. Okay, that's a kind of message we are trying to pass. Now let's say I call a divide by zero. I also enable the right one. So let's see all the outputs. Okay, now you can see that it's interesting why it is okay. It's not printing because I am not printing here. So let me print it here. All right. Okay. So now you can see that the first one gives me a result. Second one is giving me can't divide by zero. It catches here because I'm trying to divide it by zero. And the third one is the type error because I'm trying to provide a different type which is not supported. So I can provide something like 2.2 should work. It gives me an error output, no error. But divide by zero is not acceptable. It catches that. So if you know the possible error types, you can create all the excepts and then provide the meaningful message to the end user so that they know like what kind of mistakes they're doing, right? If they don't know what kind of mistakes they're doing, sort of like a generic error message, it's quite frustrating, right? You can't really solve the problem if you get to see that. Now, all this while, we are doing this, let's say, diff calculation, okay? But let's take the input at runtime. So we'll give an option for the end user to enter those values. So if you do that, I'll say num1 is, and to do that, we say input, enter the first number, okay? And I say num2, enter the second number. Now these are not numbers, okay? So these are all, let's say, let's convert it to float. That's the wrong way of calling it. So that's the conversion function. So we call that float, and then we convert it to something like this. Okay. Now then I use these two numbers to have a divide option. Now if I run this code, what happens? You can see on top, it is asking me to enter. But let's say if I copy this whole stuff into my first.py class and show you console experience. And if I run it, you can see that the console is now waiting. So I enter the first number as 100, enter the second number as 2, the output is 50. If I run the same thing, if I say 30 and then 3, it gives me this. If I run this, I say 9 divided by 0, cannot divide by 0, error coming, all fine. If I run this, I say 300 and I say hello, and there is a problem. Problem is that it is unable to convert what I'm trying to convert. So the error needs to be handled much before. Either you pass as is or you convert it later. So let's say I this change it and I don't want to convert it here. Let me do everything in the function. So I say that load AB. I convert it inside the function, kind of making it sleek. And then I run this and I say 200 and I say hello. This is not going to throw me an error. So why it is line 5 convert into a string to value error? Oh, there's a different error called value error. So there's a type error. Okay, let's make it a generic one. Put all these things and say invalid output input. Let's see how it works. It's 200 hello, invalid output. So it's more of a like generic one. So ideally, if you have, let's say, as I said, like you don't know what kind of error it will appear. So at least you should have a common except. But if you know the specific one, like except zero division error, print divided by zero, except value error, print value error. If you have, except type error, invalid input type, something on that. And then say generic error on that. So basically, what you have achieved here is that you try to capture the specific errors, whatever you know, and then you try to capture everything else, right? This could be network error, that could be anything error, right? So you can always handle error. So let me now see if I have a problematic some junk. Okay, if I clean this window and execute it, if I say 202, it gives me output. If I say through 23 0, it gives me I cannot divide by 0. If I say 300 hello, I give a like extra space here, invalid input. I can say 100 space 2 space, so still it can figure it out. So that's good. So even if there is a space, it can still eliminate that. But ideally, you should be doing a strip also here. So using the strip function, you should be taking a strip and then remove all the extra white spaces. So that's how you make a code reusable, right? So you basically have the function created, but call it again and again. That's the ultimate goal of, say, building any programming language based module. So we'll go next and clear the output and add. Any questions so far on this time? No question. All right. Now, the last part of this, what I'm going to discuss is file handling. So how you handle file, because you might be writing that to a file. To handle a file, we can open a file as open and give a name of the file and say which mode I want to open. If you open it with a W, that means I'm opening that file as a write mode. F.write, that means I'm going to write things into that file, and F.close is going to close this. So if I execute it, it basically creates a file in that folder. It should be here. So you can see that in this folder, hello world is coming. Now, if I go ahead and let's say change this to 1, 2, 3. 1, 2, 3 is coming. So it is basically replacing that, right? The same text. I don't want to do that. I want to say append it. To do that, change this to A. If you say so, if you now see the file, you see that's it's going to append that thing here. Now it is appending in the same line, but you can put a line break here. Let's say before, that way the line, first one itself will have line. Now this time I will say 100 and I execute it. The text should be here. Text should be in multiple different things. So you can see that if once the file is ready, you can also read it. So now I have a file, I have some text. Now in that, what I'm going to do, I'm going to now say f dot read lines. I'll say lines. However, there is only one line, but let's assume that there are multiple lines. For line in lines, print line. Okay, so let's execute that to see what is the output it is giving. Right now it is 1. Now let me modify the file into multiple lines. Okay, so this is now multiple lines. I execute this into here and you can see that multiple lines are appearing with the different values, right? This is how the file looks like. If you see here, maybe you say the file A, B, C, D, E. So these are all different lines. I save it, close it, and I execute this file. It gives me all of them in different lines. So this is reading the file. So you know like how to write the file. The moment you want to write a file, you need to put a W. When you read the file, you put it. Now if you do not have the file, let's say this file probably doesn't exist. It doesn't exist here, probably not. So if you enter, it is going to give you an error saying that file not found error. So you should be handling the exception through try except block. But if you haven't handled, then this kind of error will come. So this file needs to be first read. So, but when you use W, that write, if the file doesn't exist, it will create the file. So it's safe. So if I say that F as a write mode, and then I execute it, F dot write hello world, and this file doesn't exist. Okay, it exists. So let me delete that. This file doesn't exist. You notice here my Explorer. If I execute it, it's going to go ahead and create the test1.txt. So the file will be created if it is not present, right? So all this while, what we have been doing is quite a lot of things, to be very frank. So, but this is somewhat I feel is basic to pick up the Python, and Python is one of the easiest programming language because you have seen me writing the Python, and none of the context which I have written is not, let's say, clearly readable. So it is all simple English. Methods are written, named properly well. Even the syntax are very simple, so it's not like special character, extra squiggles, pointers like things. So all those complexities are missing in Python. That's why, but and it is very, very powerful. And the ecosystem is so strong that you will get a lot of libraries created for you to do things which are commonly used. For example, if you want to play with your data, there are a lot of libraries available. How do you play with the data and all these things? So once you learn this, understand the basics of the Python programming language, how to declare a variable, what is the type, what's the collection means, how do you can put a condition, loop, etc., you'll be comfortable implementing any library. It's not like you need to learn the library in and out. You may be needing one or two function from that library. That's good enough, right? You don't have to read through the library. It's like a dictionary. So in dictionary, you don't need to read every pages. Wherever you are stuck at, you pick up that page, read that definition of the word, and come out of that dictionary. So it's like that. Libraries are meant for those utility purpose. So, but if you know how to navigate through those, like you know how to navigate through the dictionary pages, you'll be comfortable doing it on your own. So with this, I want to end here, and I want to